Cool. So we are live, and people are going to start coming in slowly but surely. We'll see it. I don't see any people. Oh, here we go. We're starting to get people to start rolling in here. Well, good afternoon, everyone. Thank you for joining this webinar. We're going to get started here. Just want to let you guys know if you guys have any questions as I start to talk and as our guest speaker starts to talk, feel free to send them in the chat. And then at the question section of this webinar, we will talk and go through each one of the questions. So without further ado, we will get into this webinar. So we are going to talk about tool efficiency, tracking tool life. We have a couple things that are on our control that are really nice that talk about tool life management. We're going to get into them, but exciting is we're going to have a guest speaker. I'm going to go through a little bit of my spiel about our department and who we are and who I am inside my department. And then I'm going to hand it off to our guest speaker that I'm super, super excited that he is here today to show us what he has created on our control. Super excited what he's put together and the sophistication of the tracking of the tool life. This is so great, and I think that this is gonna, a lot of people are gonna be able to take advantage of this, and I'm super, super excited. So we will get into this and we will start to talk about that. So who I belong to is a team called Technical Application Team here in Siemens. And what I do is, my job is to work on training and work on the technical aspect of the Sinumeric control. So we are going to take something that we can utilize on the control for CNC and then train people how to use it and then actually show people how to use it. We do that in a few different ways, and we're going to go through that. So first things first, who are we and what is our team and where do we sit? So myself and Adam Caves, we sit in Elk Grove Village in the Dext. So this is definitely one of the things that we can have. We can house trainings there. We have machine tools there where we do the training on the actual physical machine, as well as we do videos. So we do a lot of things that we can kind of go in there. We have Brian Baumgartner in New York. That is our technical system engineer. He's the guy that can build the machine, the control from 0 to 5 axis, right? Then we have Chris Pollock, who's our manager that sits in New York. He also has a VTAC where he does a lot of the videos in his studio where we kind of can go through some of these other technologies that we can kind of showcase on our control, right? And we do that through a couple different initiatives that we have inside our team. Those initiatives are, one is training classes and activities. This is something that I head up. We have classes running every single month throughout the year, online classes as well as in-person classes. The nice thing about this is you can totally sign up for free for these, and there's no charge for you, and it's definitely a huge to use and take advantage of. The way that we see training is, if we can get you trained on our control, you'll see the benefit and you're going to want to use it more. Next is Our YouTube channel, Mr. CNC. If you're not subscribed, come join and subscribe our channel. We have over 100 videos and we go through everything that we can think of on our control and we put it on our YouTube channel. Like this webinar, when we're done with it, we're going to put it on our YouTube channel so you guys can view it later and then get you kind of informed on the things that we are doing throughout the year and some of the things like commonly questions. So one of the initiatives that I've taken on in my role is to just kind of do like simple how-tos, how to calibrate a probe, what's SUPA, like some of these things that we get all the time in our emails that I can just point them to a video and be like, here's a video on that certain topic. So definitely, if you haven't checked out Mr. CNC, check that out. The next is direct customer engagement. We actually have a website where you can go and fill out a question, any question that you have about it, and you'll get an expert from Siemens. So what we call it is VPE, so it's a virtual product expert. So when we were sitting around at our desks way back when, a couple of years ago, we figured that this was a great program, and we put together this program, and it's being heavily used. So you have a question about tool life management, you have a question about Cycle 800, you can go to this webpage, fill out your question, and within 24 hours, you'll get a response of someone inside Siemens that could be an expert to give an answer or point you in the right direction of what your question may be. So it's definitely a good use case. We definitely get a lot of those requests, and that is something that like Brian Baumgartner heads up. So he might pick and choose from our team to answer the question, or he might reach out to some other department inside Siemens. So this is a very good initiative for our team. One of the things that is super, super cool, it's managed quarterly and it is updated on our website, is something called the Content Manager. Content Manager, it has every link inside of our YouTube channel. This puts in kind of an organized kind of way of seeing all the videos on our YouTube channel, and then you can kind of filter it. You can say, do I want to learn about milling, or I want to learn about turning, and it'll actually filter out the videos of some highly recommended videos that you should watch in order to do that. As well as you can filter, like, I just want to see all the videos that have the word probe in it. You can totally do it in this file. Also in this file has every single link to manuals for Sinumeric 1, has all the single links to manuals for 840D and for 828, resources for links, how to sign up on our content manager, how to sign up on our contact list, and some important things to find us on social media. So this is a very good document. If you have a Sinumeric control already, this should be a document that you know about, because simple little questions, they all come up, and we continue to add videos on our YouTube channel. We're going to continue to add to this list. So you can download this from our website. It's really, really, really powerful thing. You could find it on CNC for You, and it will come up as we go through that. Then we have the contact list. The contact list, this gets you to how do you find out about our webinars? How do you find about our YouTube lives that we have going on month to month? So this is definitely something that really good. Whenever we have an event, we are definitely going to use this list to push out how and when we're going to have either YouTube live or a webinar. So this is a list that we use to email everyone to inform them that we're having these events. And then some social medias that you can find us on. And then myself, I'm Dan Struble. I'm the Technical Application Manager in Elk Grove Village. And this is the contact information for me. But without further ado, I wanted to talk about our guest speaker. So our guest speaker comes from something that you may or may not have seen on YouTube as well, and throughout various platforms like Facebook and Instagram and YouTube Shorts, is Jessie Smith from Titans of CNC, and he comes with a lot of background. This is the thing that's really great, and what he's achieved with the tools that he's been given, he's been able to achieve a lot, I think, with this tool macro that is very exciting to share in this webinar. He comes with 18 years of experience. He was a programmer and a machinist at the same time, so he knows how to run machines. He's very good at it. He's been at at Titans of CNC for over 3 years, and he's been doing content and sharing things in the academy. He comes with a real world background, and he specializes between 3 to 5 axis machine operation, application support, and for machine tool customers. So he has a lot of background. Some of the parts that you see on the screen is what he's done too. So he knows a lot, and what he's done on our control, he's kind of taking the bull by the horns and created this really sophisticated macro to track tool life on something that we have on our control. So he's going to break it down from you in this webinar. So without further ado, Jessie, if you want to come on and start to share your stuff, I welcome you to this webinar and thank you for sharing what you've created.
Awesome. So you got my screen here?
Yep, absolutely.
Yep. So thank you for the introduction, Dan, and all the kind words. And I'm really honored to be here today and to have this opportunity to be a guest host on this webinar and to show everyone something that I've been working on that I believe is going to help out a lot of shops. So whether you're a job shop or a production shop, I believe everyone can benefit from the topics that we're going to be covering here today. And that is how to use your Sinumeric control to generate a simple data-driven report of your actual tool life so you can implement tool life monitoring or tool life management properly. So today we're going to look at, the benefits of tool life management. We're going to talk about, what those are, and then we're going to go over to run my virtual machine, and I'm going to show you some real life examples, how we activate tool life management on a Sinumerik control and how we add sister tools. And because I realize like some people on this webinar is probably already using tool life management, so you already know how it works, but not everybody is. So not everybody is going to know how to do that. So we're going to quickly go through that. And stick with me because then we're going to back up and I'm going to show you how to add tool life tracking using the macros that I've wrote and to be able to generate a data-driven report. And I'm going to take you through that process of how to run tool life management using that tracking macro. And then from that, it will then we can properly implement tool life management, in other words. So then after that, we're going to talk about some of the limitations with the macro, and I'm not going to hide it. You're probably going to see them right off the bat, and I'm going to tell you why I'm okay with it and why there's limitations and maybe even how to get around this to make it even better. And then always at the end, like Dan said, we'll have a Q&A at the end, but certainly Dan will be watching the chat throughout the webinar. So if you have questions come up, ask them in the chat and we'll get them answered for you. So why tool life management? So why would we want to spend the time to set up tool life management? Is it actually worth it? So if you're a production shop, chances are you probably already know the answer to that question, and it is absolutely worth it. But maybe you're a job shop that you don't really have to worry about tool life management because you're changing tools out and parts out so much. Well, eventually you're going to have a part that is going to have some type of volume that you need to implement tool life management for, or maybe you're doing difficult materials, something like Inconel that you need to keep a watch on your tools so they don't break. So to answer this question, I want to ask another question, and that is, without tool life management, when do you know to change your tools? So how do you know when to change your tool? And the things that I can come up with is, well, you wait until they break. And that's a pretty good indication that you need to change your tool out, right? Well, another way is maybe you listen for dull tools. If a tool starts getting dull, it's going to get louder and louder, right? So you're going to hear it and hopefully act on that before it gets to the point of breaking. The problem with that is that's really only pertaining to roughing tools and maybe some drills. You're not going to be able to hear a finishing tool get dull. I hope you don't anyway. But maybe for finishing tools, we start seeing our surface finish starting to degrade, or maybe we get some notching on our end mill and we start getting a line or really bad surface finish, or maybe our walls start tapering. So that's a good indication to change our finishing tools. But the last one I could think of is we just guess. We just make up a number that we say of like, oh, this tool can get 10 parts. And so change it every 10 parts. But you can see without tool life management, none of these are really good indications of when to change a tool or when to change it properly, right? So all of these are going to end up with problems. So right off the bat, we can see that the benefits of proper tool life management. Now, when I say implementing tool life management, I mean proper tool life management. And right off the bat, we can see that we could increase our throughput by way of scrap reduction if we change these tools out before they break. You know, this all stems from my time of working at Smith & Nephew, which is a large medical device company. I was in the bone plates division, and all of our machines in the building ran bone plates, 700 catalog items, you know, and the biggest tool we ran was a 1/4-inch end mill. And with 35, 40 machines in the building running at one time, you can't hear a 1/4-inch end mill getting dull, right? So most of the time, or pretty much all the time, the only time that we knew to change tools was when they broke. The problem was every time a tool broke, that meant a scrap part, because the operators normally wouldn't catch it until they done took the part out of the fixture, and then they noticed, well, some features aren't there. It's got a big piece of carbide stuck in it. Whatever it was, that meant a scrap part. So by implementing tool life management, and we catch these tools before they break, instantly we can start reducing our scrap and start increasing our throughput. Another big benefit to that is also increased spindle utilization by decreasing our downtime. So we're being proactive by changing the tool out before it breaks, rather than reactive, which is changing it out after it breaks. So if we wait until these tools break and then we change them out, that means the machine has to sit while the operator calls the tool up, takes it out, goes and inspects it to make sure that the holder isn't damaged, and then change the tool out, put it back in the machine, touch it off. Now he can get started. The whole time the machine is sitting idle. And if that spindle is not turning, we're not making money. So this is the big part where tool presetters can really come involved, and sister tools. So if I'm implementing tool life management and I have sister tools installed, that means that when a tool runs out of tool life, the machine can keep running because it has a sister tool to take its place. It's running while the operator changes the tool out at the ATC, goes and changes the tool, puts it back in. Now, obviously, you'd have to stop at some point to touch that tool off if you're doing it inside the machine, but that's going to be far less downtime than it would be if you were waiting until the tool breaks and then doing the whole process. But this is where also a tool presetter outside the machine can really shine, because if you're running something like RFID chips and you've got a tool presetter and you set that tool length, you put it back in the machine, now you're not ever having to stop, and you're getting the most spindle utilization you can get. Another big benefit would be manage your tooling costs. So like we said earlier, if we're just guessing at how long a tool is going to last, and we say, oh, this tool is going to last 10 parts, change it after 10, but it can actually get 30. Well, that's 3 times the amount of parts we could actually get with that tool that we're missing out on. So our tooling costs could go through the roof because of that. But it also, on the other end of that, if we're waiting until tools break and potentially scrapping parts, well, that could get even more expensive, right? So we want to implement tool life management properly. And another big benefit to that is we actually have the ability to forecast our expenses. So if we're a production shop and we know how long or how many parts we've got to make in a year, we know how long each tool runs in each part, and we know what the tool life that we've set on that tool, Well, now we can get a good forecast of how many tools we're going to run throughout the year and how much that's going to cost us. And not only that, we can know how many tools we need to stock, because the last thing you want to run into is having your machine down and you're not able to produce parts over a $20 3/16 end mill that we ran out of stock on. So tool life management can be a really good step in the right direction for managing those tools. And the last one I want to talk about is kind of works hand in hand with the macro that I'm going to show you today. So tool life management and this macro with tool life tracking can find anomalies and inconsistencies in your process. So if we're getting sporadic tool life out of a tool, then that could mean a couple different things. Number one, it could highlight that we have an inconsistent process. Maybe our tool is just, whatever it's cutting, maybe it's recutting chips, it's trying to cut down in a pocket, and we need to do something about that because that's causing the tool to have sporadic tool life. So as you can see, this graphic here, this is the output that you're going to get from my macro, the data-driven report that I said. It's going to be very simple. We're seeing that this tool, this half-inch end mill, lasted 30 minutes the first time it was changed. Then it lasted 2 minutes, 17 minutes, 28, 4. You can see this is very inconsistent. So when we talk about process improvement, I instantly can see this is probably the first place I need to look, because I have a problem. If I can't get to the point of running tool life management with this tool, if it's so far, if the tool life is spaced out like this, there's no consistency in it. And I'm definitely never going to run lights out if I'm having to chase tool life like this. And Dan had mentioned something too that was a very good point, that if you have a consistent process with a tool and all of a sudden you start seeing something like this pop up, and that tool is not supposed to be like that, that could actually show you some inconsistencies with your tool. Maybe the manufacturer, maybe they switch vendors for carbide, because not all carbide blanks are made equal. So this could actually catch a problem there as well. So we see some really good benefits by implementing tool life management. So now I want to step over into run my virtual machine, and I want to take you through what tool life management looks like on a Sinumeric control. So we have 3 ways that we can set it up. We can use time, which is in minutes. We can use workpiece count, and we can use tool wear. Now, this is what really started making me fall in love with the Sinumeric control when Chris Pollock came down to our facility and he started training me on all the nuances on the Sinumeric control. When he got to this point, it immediately made me think back to all the struggles that we had at Smith & Nephew when it come time to implement tool life management, because we did it on a different control. And what I really love about this is that if we use something like time or wear, we don't have to have any program intervention. There's no M codes that I've got to figure out, no tribal knowledge that very few people out there know about. I don't have to do anything to my program to implement tool life management or sister tools. Now, there is one little line that we have to add for workpiece count, and we'll look at that in a second. But as far as time and wear, we don't have to do anything to the program. And when you were somebody like us that had 700 catalog items, that could be a serious problem. Because in the medical device industry, if a program is approved and certified, if I make any change to that program, like adding M codes, things that could change up that program, that means that now I have to switch that from approved to not approved, which means they can't run production until I go out there, they get the machine set up, I run a first article, send it to quality, and they inspect it, sign off on it. Now I can change it to approved and we can run production, which typically that meant at least a day of being down. So when you have to do that 700 times, that can be a big problem. So we're going to look at this on a Sinumeric control and see how much it's better. So this is going to be our example part that we're going to run through. It's just a simple part that I modeled up to basically get the point across. So we're going to run a face mill across the top. We got a couple end mills that we'll rough and finish the profile with. We've got a 12 millimeter tapped hole on one side and 4 1/4-inch through holes on the other. So we'll start implementing different tool life management strategies to this part. So I'm going to hop over here into run my virtual machine. And I've already got the part set up on the machine and the program called up. Now, quickly, I want to kind of open this program up. I'm not going to take you through everything, but I just want you to see this is a basic program. Nothing special is going on here. So what I want to show you is I want to take you through how I would handle this if I'm a shop that wants to run tool life management in a production environment. So let's say I just proved this part out and now I'm ready to run it. And I'm going to run it in production and I want to set tool life. So I'm just going to kind of run through here for the first go. Nothing's different about this. There's no tool life management set. This is just normally how it runs. And I got a setting on here I need to turn off real quick for collision avoidance, but we'll ignore that for now. So if we want to set tool life management, we want to go to our tool parameters page and we want to go to tool wear. Now, when we go to our toolware page, we will see this column here, and it will have a TEC at the top. So this is where we set tool life management. And I'm just going to let this finish real quick. It's almost done. It's going to run a chamfer tool, and then we'll run our tap down that hole, and then it's going to complete. All right. I'm going to turn collision avoidance off so we don't keep getting that. All right, so if I want to add tool life management now to this, the first thing that probably makes sense is maybe we want to add tool life time to our 1/2-inch end mill. It's got a lot of material coming off here, and let's add tool life management to our 1/2-inch end mill. So what I want to do is fly out this menu here, and I see I've got 3 options: T, C, and W. So time, count, and wear. So if I select time, now I see these 3 fields populate. For tool life, this is how much life is left on the tool. I see a set value. This is how long you want this tool to run, and then a pre-warning limit. So let's say I want this tool to run for 30 minutes. So that's where I would put this value here on set value. Now you can see that when I put this in here, the tool immediately disabled and I have a red X over my tool icon. That is because on a Sinumeric control, the actual tool life, this is called the residual tool life, this does not count up from 0 to my set value. It counts down. So when it sees a 0 here, it's thinking that this tool is out of tool life. So what I want to do, if I want to say this is a brand new tool, I'll just make this number the same as my set value. So now what I'm telling the control is that this tool has full tool life. So what I'm going to do now is I'm going to call up another program. This takes, you kind of seen this takes quite a bit to run through. It takes like 40 or 50 seconds. And I don't want you guys to have to sit here and wait on that every time just to see one thing. So I've wrote another program. It's the same exact program. It's just I'm skipping everything after that 1/2-inch end mill. I'm just doing it with a go-to statement. So if I hit cycle start on this and I come back to my tool area, I'll see that as this tool runs, it's not going to be second for second. You know, it's going to have a little bit of delay, but I'll see this start counting down. So it's going to keep counting down every time it runs, however many minutes it's running in the control. It's going to count down until it reaches 0. Now, one thing I didn't go over was this pre-warning limit, and I apologize for that. This is optional to set a pre-warning limit, but if you want to, you can set this, let's say 5 minutes. So once this tool starts running, every time it runs, it's going to count down. And when it gets to my pre-warning limit, it's going to pop up with a yellow icon. I'll show you just a second when this gets done. It will pop up with a yellow icon on our tool icon, and it will typically have an alarm at the top that says that the tool, it will give you the tool name and say that it has met its pre-warning limit. It's not an alarm that's going to make you stop. It's going to keep running, but it is going to pop up and tell you that it's met its limit. So every time this runs, it's just going to keep counting down all the way till it gets to that. And there's that icon. As soon as we read this pre-warning limit, we'll see this yellow triangle pop up. And typically you'll see that alarm at the top, but it's going to do that all the way to 0. Now, once it reaches 0, we see that just like before, it automatically disabled the tool, and it's got the red X on our icon to show us that it's disabled. So now if I go to run another part and this is disabled, and I hit cycle start, I'm going to get an alarm. It's going to say no tool is available in tool group, whatever the tool name is for this program. So it's going to tell me I can't run because I don't have a tool to run. It's disabled. So this is the point that it's going to force you to do something about it, force your operator to do something about it. So hopefully they go in and they change the tool to a new tool. When they put it back in, they'll need to come here to the toolware page, highlight the tool, and click reactivate. Once we reactivate this tool, you'll see it will automatically re-enable and it will reset your tool life. So now it should let us run. And I want to put this back at 0 because I want to show you how I hit cycle start, I get the alarm. This is where sister tools come into play. Now, if I was to let this, even with tool life management, if I was to let this run out and I don't have a sister tool, that means the machine is going to stop, alarm. The operator is going to have to change the tool out, the whole gig that I said earlier. So we're not really going to gain anything because the machine is going to sit idle while they change the tool out. But if I have a sister tool, that means it can keep running while the operator changes the tool. So I'll show you how easy that is to create. So if I want to come here, I'm just going to create a new tool. And in order to get a sister tool, all I have to do is give this the same exact name as the tool that I want to mimic. So I'm going to name it this 1/2-inch rougher tool. So you can see, as soon as I create that, I get under the sister tool column, ST column, it automatically populated with 2. And that's because we already have a sister tool 1 in there. So we just added the next number. So I want to give it some values here, say like this is actually a real tool. And then what I want to do is I want to come here and I want to set tool life. So I'm going to tell it, it's going to be the same exact tool than the first tool. It's just I'm creating, we call them sister tools. Some people call them redundant tools, whatever you want to call it. So I'm going to give it the same values here. Now remember when this tool was not created and I hit cycle start, I got the alarm that there was no tool in existence for it to run. But now when I hit cycle start, notice it starts running. And it calls that tool into the spindle, the sister tool 2. And it's going to do the same thing. It's going to start running down the time until it's met its limit, and it's going to disable it. But this is letting the machine run, giving your operator enough time to change this one out and reactivate it. Now, one thing I do want to note here is that just because this tool, the sister tool 1, is now reactivated, doesn't mean that it's going to switch back to it. Now, notice when I hit cycle start here, both tools are activated, but it's going to call sister tool 2 back into the spindle. It's going to keep doing this until its tool life reaches 0 or unless you disable it. It's not ever going to go and choose a different sister tool until this one is disabled. So that is how easy it is to implement tool life management and sister tools, redundant tools, on a Sinumeric control. I didn't have to change anything on my program. I didn't have to do anything special, look up a bunch of M codes, none of that. So now that our sister tool has been running, it's going to keep running until I disable it, like I said, and then it's going to switch back and forth between the two. Now, what this is, a sister tool, if you don't know, a sister tool would be just like the exact same end mill. So this is a 1/2 inch end mill. I build up a 1/2 inch end mill to be able to cut this part. I put it in a hydraulic holder, whatever I put it in. What I want to do is I want to build a second tool the exact same way. It's got to be the same exact end mill, same corner radius, same length of cut. And all that. It doesn't have to be because the machine doesn't know it's different, but it needs to be, right? So whatever tool I'm using for this, I want to just build that same exact tool and enter it into the machine. And when I give it this same name, it will give it the sister tool too. It will be its own separate tool. It just has the same name. That's the only difference. So I'm going to go ahead and delete this tool just so we don't have to keep looking at it and it get convoluted here, because that is time. So we went through time and we went through sister tools. So let's look at implementing count. Count is the one thing that you do have to input something into the program. And it's because it's a little bit more involved or more powerful than just simple, every time the program runs count 1. And I'll show you what I mean in just a second. But maybe for count, it makes the most sense to add it to my drills and my tap maybe. So let's say this drill right here, I want to add tool life count. So I'll select C for count. And I'll see the verbiage here change depending on what tool, what type is set. So for my quantity, I'll say, oh, this drill can do 100 parts. So I'll set it for my set value and my quantity. And again, pre-warning limit is optional. I'm not going to worry with setting it because it doesn't really matter. But I want to set this tool as well. So let's say this tool can also get 100 parts or 100 times that it can run. And I want to do the same thing for the tap. So let's just say these 3. Now, if I was to run my program just like it is, I could run it 1,000 times if I wanted to, and this is never going to count down. It's not like if I run my program and when it reads an M30, it's going to count down to 99, 98, 97, so forth. It's not going to count down anything unless I put something in the program that tells it to count down for every tool that is set to count. Now, let me show you what I mean. So if I go to my program, I'm going to close this one out. I'm going to call this one up. The same exact program. The only difference here, like I said, to save us a bunch of time and not have to watch a bunch of tools simulate, I'm just skipping all of the roughing and finishing tools, and I'm really only running the drills and the tap for this. So just kind of trying to be transparent here. There's nothing tricky going on. I'm just trying to speed things up here. But let's say for this example, I want to count all these tools the same, and I just want to count them by the part. So I'm running one part in one vise, and every time it runs, I want to count it by one part or 1 on my count. So if that's the case, all I would have to do is come here to the bottom of my program and add this set piece 1. So the set piece is the name, and whatever's in parentheses, that's the number that it's going to count by. So if I have this count to set piece 1, I hit execute for this. Now when I hit cycle start, you'll see the drill, this drill come in. The 1/4 inch drill is going to drill these 4 holes, and then it's going to come in and tap this hole. It looks like I got a magazine error. I don't know why, but it's not important. So now I see, now that it read set piece 1, it counted down by 1 for all 3 tools. Likewise, I can go back to this and I can say set piece 3. Maybe I'm running a pallet and I've got 3 parts that I'm running per program. So I can say set piece 3. Now when I run this, it's not going to reduce. So just because that tool ran doesn't mean it's going to take away from the number. It's not going to take away from this number here until it reads that set piece command. But you can see it was 99. We subtracted by 3. So everything that had set to count that ran is going to reduce by 3. So that is why you have to add this to the program. Is it's a little bit more powerful and more customizable than just saying, hey, every time the program runs, count down by 1. But on top of that, I can also count down each tool individually. So if I go back to my program, let's say I want to count by per hole, not necessarily per part. So I want to count these same tools, but I want to do it per hole. So my tap drill and my tap is only drilling and tapping 1 hole. So maybe for that, I want set piece 1. And I'm leaving this here at the bottom because the last tool that runs is my tap. So essentially what I'm saying now is for my tap, do set piece 1. Now I'm going to come up and I'm going to find these other drills in the program. So the first drill that runs is this tap drill. And I want to add set piece 1 after it. So as soon as it runs this tool, it's going to read set piece 1. And it's going to subtract 1 from that tool. But then the very next tool that runs is this 1/4-inch drill. And as you can see, I've got 4 holes on it. So I want to count it by 4. So I'm going to do set piece 4 for it. So now I've got set piece 1 for this drill, set piece 4 for this drill, and then set piece 1 for the tap. So now if I run this program, come back to my screen here, we see we're at 96 now. That drill goes to 95. This drill will go to 92. And then my tap will go to 95 as well. So I just wanted to show you an example of how powerful count can be and the different ways you can implement it depending on how you want to have it counting by. So that's pretty much it for count. The last one would be wear. And we don't really have to run this simulation because it doesn't really matter. But let's say the one that makes sense for tool life wear would be maybe my 3/8 end mill that's finishing the part. So what I want to do is I want to click this field and I want to go to the W for wear. Now the big change here, would be we don't have to fill out this field for the residual. As you can see, it's grayed out. If I click off of this, it's grayed out. So the only thing that I really have to set here is the set value. And let's say I've determined that this end mill can have up to 5 thousandths of wear before I need to change it. Now notice when I input it here, it auto-populated on this side. Now I could run this program 1,000 times. It doesn't matter. This is never going to change until I start adding values here to my tool life wear or my tool wear. So let's say I just ran this part and I took it out and I measured it and it was a little big and I needed to subtract 1 thousandths from my diameter. So what I want to do here on my radius is I want to subtract it by 1 thou. When I do that, I see this auto-populate subtracting that 1 thousandths to my residual wear, my actual wear. So now when I run it, I could run it 1,000 more times. It doesn't matter. This number is not going to change until I change it here. So every time this tool runs and we adjust this number, you'll see it adjust here. Now, it doesn't matter if this number is in length or radius. They're not going to compound. So if I put -1 thou here, you see it stays at 4. It's not going to compound on each other. And the sign doesn't matter. It doesn't matter if it's negative or positive. I can change this to 1 thou positive. And you see the number doesn't change here. The only thing that matters is it's looking at the largest number here, or I guess the smallest if it's a negative. So that's the only thing that's going to change this. So if I go to 2 thousandths, oops, sorry, hit the wrong button here. If I go to 2 thousandths, you'll see it go to 3. Go to 3, so forth. Pretty easy. All the way to 0. Now, once we reach 5 thousandths of cutter comp, we say, well, you've reached your limit. You have no more. Now I'm going to disable this tool, just like the others. So that's really the difference between the three. And that is how you would normally use tool life management on a Sinumerik control. It's just that simple, which is all fine and great if you know what values to put. So that is the big question, right? How do I know that this half-inch end mill is going to run for 30 minutes? How do I know that this tap and these drills are going to drill 100 holes before they need to be changed? That's the question that I'm going to try to answer for you today. And that's what I really set out to do with this macro. Because that can be really difficult to find. So what I want to do is I want to take a step back now, like I mentioned earlier, and approach this like we did in the very beginning, where I say, I've just proofed this part out. Now I'm ready for production. I want to implement tool life management, but I don't know what my tool life is going to be. What is my daily routine or my routine to run this part to find that tool life? So I think if we go through it like that and I show you how it works, and then we start dissecting it to see what you need to do to set your machine up to get it to work, because it's super simple. Okay, so I'm going to go to my program manager. I'm going to call up a new program. Now this is going to go through the entire program. I don't have any jump commands, but it's the same exact program that we've been running. The only difference here is you will notice a couple sub programs. So I've added a sub program here after each tool call, and I've added a sub program at the bottom of each tool when it's finished, just before it calls another tool. So I have that for every single tool. Now we'll kind of go over all of this later, and I'll show you exactly how to implement this and why, where they need to go. But for me, I'm hard coding this out. You know, I've added this to my post processor. So every part we post here at Titans of CNC, this outputs, whether I'm tracking tool life or not. So that I've tried to make it very simple to where you don't have to do any post edits after you add this in here. So whether you're tracking tool life or not, it doesn't matter. So I'm going to hit execute for this program. Now, just like before, we set this part up. We're now ready for production. I've posted my program. I've called it up. Now what I want to do is I want to go to my tool page in my toolware, and I want to set these up. Now in a real world environment, I don't know if I said this earlier or not, but if I'm really running production in the real world, I want these set on all of my tools, because eventually they're all going to wear out. But for the purposes of this webinar and to keep things from getting so convoluted, I'm only setting a few tools. So I want to set tool life, but the problem is I don't know these numbers yet. So what I want to do is I want to set it to something very high, something that will never be reached. So let's say I'm going to put this at 1,000. And I want to do this for every tool that I want to track. Now, I cannot stress this enough that this needs to be a number that cannot be met. You never want this to reach 0, because if it does, before this changing it out, when the operator does change it out, all it's ever going to output is whatever number is here. And that's not going to give you a true number. So if you're running something like aluminum and you think you can get 1,000 holes out of your drill, put it at 2,000, something like this. Doesn't really matter what the number is, as long as it can never reach 0 here. So we're forcing that operator to change this out. Now there's a couple disclaimers here I want to mention. Notice how I'm only doing this on the ones that I have set for time and count. And that's because I've only wrote the macro to account for these two. I did not write it to track wear, because I felt like wear is something that is your judgment call. It might not be, maybe somebody has a better example, but the only time I can think of for using wear would be my finishing tools. And at that point, it's going to be a judgment call on you, how much wear you're okay with having before you need to change that out. So since it's a judgment call, I'm not really tracking it in the same way that I'm tracking time and count. So we can add that. If anybody wants it, we can add it to the macros. It's not a big deal. It's just I didn't see the need for it. So what we want to do, we want to make sure that for all of our time and count, we set this to a large number. And then the only other thing we got to do is we have to set an R variable. So what we want to do is come over here to our user variables, and I'm going to arrow over to R60. Now, as you can see, I've got my comments turned on. If you don't know how to turn these comments on, just hit this over arrow, and you can see display comments right here. I like to put comments on all variables that I am using, because 2 days from now, I'm going to forget everything about these. So this is just a quick reference for me. Now, I am using R60 through R66, and we'll talk about this a little bit later. The only one that you have to really worry about is R60. So if you have this set to a 1, if I change this to a 1, that means I want to run the macros. I want these to run in the background and track my tool life. If you don't want to set tool life, if you don't want to track anything, if you're done with it, set it to literally any number other than 1, and it will not run the macros. But for now, for our example, I just loaded my program. I set my tools to a very large number, and I want to run tracking. So I want to set this to 1. And now the only thing that happens is you just tell your operator to run normally. So they're just going to start running the parts. And as they run, and they naturally are going to change tools out, whatever method that may be, that's when they have one responsibility to do. Now, this is one of the downfalls of doing it this way, and I'll cover this when we talk about the limitations, is I don't really like to have any control from the operators, but this is the simplest way I could think of to implement this macro. So I'm kind of okay with leaving it in there for now, but we'll talk about it later of how you could get away from doing this. But as your operator is running his parts, they will inevitably need to change their tools. So at that point, that's when we need to come in here and tell your operator that as this starts getting some time on it, or whenever they change a tool, they need to come in here and reinitialize or reactivate the tool. So even though this doesn't reach 0, because remember, we don't ever want this to reach 0, they need to come in here when they change the tool out and hit reactivate. When they hit reactivate, it will reset this tool life back to whatever the set value is. They can either hit reactivate or they can just type it in. Either way, doesn't really matter. But they do need to hit reactivate. So once they do that, I'm actually going to run this. I'm just going to put some numbers in here that I make up. 950. I'm just going to literally make up some numbers. And I'm just going to run this one more time. So I run this one more time all the way through in order for it to capture what number is in here. But once I do that, we will get some data that we can work with. Now, while this is running, I want to go to our program real quick, or program manager. Under this Workpieces folder, I want to show you that there's nothing here but the temp folder. Okay, there's no other folders here. Now keep that in mind. So now that I've come here and I've ran these parts, simulating your operator running his parts, and let's say now he's getting to the point where he's starting to change out tools. So if I come here when this gets done, all right. So let's say this end mill needs to be changed. He changes it out. They come here and they hit reactivate. Now when I hit cycle start, something's going to happen when that tool is read into the spindle. Now when it sees that these two numbers are the same, it's going to say, hey, that's a new tool. So write out the information that you just stored for that. So if I come back here to my program manager, notice how under Workpieces, now I have a new folder here. This was not there a minute ago. So if I fly that out, I've got a new program in here. So if I open this up, here is our report that we're getting from the macros anytime a tool is changed. We're going to see the tool name, so end mill, half-inch rough, and we'll see some more data for this tool. We'll talk about this in a minute, but sister tool 1, edge 1, D1, and internal tool number 3. That's the internal tool number assigned to this tool. This tool lasted 22 minutes. So what's going to happen is every time your operator changes these tools out and they come in here and they reactivate these tools, it's going to capture that data. So what I would recommend you doing is just have them run this part for, and it depends on the part and how many you run a day and a week and all that, but run it for a sufficient amount of time that you know you're going to get some good data. So let's say after 3 days or a week of running, that operator should have changed out several tools by now. So what you can do is go to the machine, go to this program manager, and either save this to a USB, take it back to your computer, or just analyze it right there on your machine. But you're going to open this up. I'm trying to wait till this gets done because it's going to interrupt it. But what you're going to do is you're going to open this up and analyze the tools that have been changed. So every time a new tool is changed, it's just going to keep amending this program, and it's just going to keep adding it to the bottom. So what you're going to end up with is something like this, and I'm just going to take this first tool and copy it down, just kind of as a simulation that this tool has been ran several times or changed out several times. So now that you've got some good data here, I can go in and I can categorize these and say, hey, every time this tool is ran, that was me earlier, I'm going to average all these together and get a good baseline for how long that tool is lasting. And then maybe I go in and I say, okay, that's a good average for how long they're lasting. Let's put a little safety factor in there. Let's reduce that number by 10%. And that's going to be my proper tool life management. So what I can do now that I've analyzed the numbers, I've got good numbers, I'm going to come here to my toolware and I'm going to input those numbers. So I'm going to say this one is actually averaging 20 minutes. So I'm going to change that to 20. This tap could get 165 parts. This drill could get 225. I'm just kind of making up numbers here. You get the point. This one got 130. So now I've got true numbers based off data from how this part has been running to implement better tool life management. So now that I've set these to proper amount, there's no reason for me to keep tracking the tool life, right? Because now these should go to 0 every time. Okay, I've chosen a safe number that can get the most out of my tool and still be safe enough to where it's not going to break, unless there was something, I got a bad batch of tools or something. So I want this to go to 0 every time. And this is where I start implementing sister tools. If I'm in a high production environment, I can create a sister tool for every one of these tools and implement the same tool life management for all of those as well. So there's no sense in me tracking tool life management and keep making that program bigger and bigger. So now all I have to do is go to my user variables and set this to 0. So it's no longer going to track those tools or track the tool life. So that is how we can find a very, that's how we can find our tool life from actual data from the machine. Now we're not having to rely on our operator to write down the numbers like, hey, when you're running these, write this down. And every time you change this tool out, write down how many parts you got or write down how many minutes it cut. That's never going to go over well. I can promise you, I've been there several times. So by doing this, the only thing I'm basically putting in his responsibility would be to, when this tool is changed, to come here and reactivate it. Okay, so that is how it works. So now let's go back and kind of dissect it to show you how I got to this point. So we'll come back to my webinar here, or the presentation. Now there's something I want everyone to keep in mind when you're seeing how I'm implementing this. And this is something that I like to say all the time. And that is, if a solution is too complex to implement, it's not going to get done. Simple and effective beats ideal and unused every single time. Now, what I mean by that is, like, we all have the best intentions to do stuff like this. I've worked in shops in the past where we wanted to implement tool life management or something very similar. But like I said, with some controls, it can be such tribal knowledge and all these M codes that nobody knows. And it can be really difficult. So that means that I don't know how to do it. So I'm going to have to sit down and figure it out. And I just don't have the time to do that. I've got to get parts out the door, you know? So next thing you know, you're 5 years down the road and you're still trying to think about how to implement this that you were thinking of 5 years ago. So what I want to tell you is the way that I'm implementing this is not the most effective. It's not the best. There are some limitations with it, but I wrote this in a way that is going to be appealing to the masses. I feel like everyone could easily implement this into your process without having to do anything super risky and really complex. So that's the way, the mindset that I'm taking in showing you how to implement this. So to implement this, we need 4 steps. First, you'll download the 2 macros and enter them into the NC memory as in the subprograms folder. You can put them wherever you want. I find that it's easiest to go to the subprogram folder and just do a call command. You can put it somewhere else and do an external call if you want. But I haven't said it yet, and I apologize, but these macros I'm going to give to anyone who wants it for their Sinumeric control completely for free. Reach out to us. I think we'll probably have a link on the YouTube channel or somewhere. We'll figure that out. Reach out to me or Dan, and if you want these macros, and I will give them to you. But after we import these 2 subprograms into our machine, we want to verify that that you have variables R60 through R66 available to you. A lot of shops out there, especially if you're running production, a lot of you might be running several macros that you've wrote and you don't have enough, or you're using these R60 through R66. That's no problem. Just find 7 variables that you're not using and do a search and replace in these 2 macros and just replace them. Or you can create your own global variable. We talked about earlier. So probably the most complex stage of this, and I'm going to explain this to you, and hopefully I do it in a non-confusing way, but we will need to create a global variable to store our data. Okay. So that internal, or the residual tool life and your set point tool life, that's going to keep getting overwritten, right? So we need a way of storing that data. So if somebody overwrites it when they put a new tool in, we have that data stored somewhere, and we're doing that with a global variable. And I will show you how to create this and the syntax that you're going to need. And then the last thing we need to do is just add these 2 lines to the program. So we're adding it as a subprogram call right to our program. So how does this work? So what happens? when this runs. So as soon as a tool is called into the spindle in our program, the first macro that's going to be read as a subprogram is our tool life write program. Now, what's going to happen there is that program is basically looking at the tool that just got called into the spindle and it's saying, is this a new tool? It's going to answer 3 questions. Number 1, it's going to say, is the tool that's in the spindle using tool life management? Is it set? And if it's set, is it set to time or count? Because if it's not set to tool life management and a tool life time or count is not set, it's just going to end the program and go back to your main program. It's not going to do anything. The next thing it's going to say is, okay, is this tool using, is it a new tool? And if it is a new tool, has that tool been ran before? And if all 3 of these are yes, then it will write the data that is stored in the global variable. So I wrote that last question. So is the tool been ran before, to keep you from getting brand new tools that you write, the first time you put this program in there, the first time you create this tool, it's not been ran before. So obviously it's going to be a brand new tool, right? So it's going to be 0 for your data because it hasn't stored any data. So I didn't want you to get a bunch of reports saying this tool ran for 0 minutes or this tool ran 0 times. So I put the logic in there that says, okay, if this tool hasn't been ran before, don't write anything out. But only if those 3 conditions are met will it write out that program. Then it will jump back to your main program. It's going to run your toolpath. And then after the toolpath runs, you'll see you'll input your last sub-program call, which is tool life record. And that's going to be right before it calls another tool. So the last thing it does before it calls another tool. Now, what that program is going to do is it's going to, again, see what tool is in the spindle and then look at how long that tool just ran and then store that into the variable. And then it's going to call the next tool up and go through the same process with that tool. So if we look inside the tool life record, I'm not going to open the programs up and go through this. It would take all day to break down this macro, but I will kind of go over a couple of the highlights of it. So the tool life record macro will, again, look at this set value and store that on variable R65 and store the tool life on R66. And what it's going to do is it's going to save out this data, the difference between these two, to our global variable. Now, our global variable is tied to 2 things. It's tied to the edge that we're using, okay, D1, D2, D3, and it's also tied to the internal tool number. And I'll show you where to find this in just a minute. Because chances are most people is never really worried about this tool number. So what it's going to do is you're going to create these global variables and it's going to assign this number or do the math, assign it to this variable for that tool. Now our tool life write program is going to look very similar. At the top of the program, both of them look very similar where it has these lines here that extract the data from the tool. And I've tried to put comments for anybody that wants to get in and dissect this. I've put comments on literally everything to try to make it somewhat digestible. But I know it doesn't matter how good you are in macros. When somebody else writes a macro, it's very difficult to understand. But what it's going to do is it's going to look at what tool number is in the spindle for that internal tool number. It's going to start with D1. It's going to go through all the different edges. And it's going to see if tool life is set, if it's set to time or count, and then jump to the appropriate place in the program. But what it's going to do more than anything, like I said earlier, is it's going to look at this set value and look at this tool life that is residual tool life. And it's going to compare these numbers. And it's going to say, are these 2 numbers the same? And if they are, then that means it's a new tool. And then go on to our other questions that we already went over. And if they're not, just end the program because it's not a new tool, so there's nothing I need to write out. Now for our global variable, like we've seen earlier, this is going to be tied to the edge number and the internal tool number. So what that would look like is we're going to create multiple variables. We need to have enough variables to cover however many tools we're running. Okay, now you see in my example, I've only got like 8 tools, or 6 tools actually, but you might be in a shop that has 100 tools or 200 tools. So you need to create enough global variables to accommodate that. And likewise, not only does it need to accommodate how many tools you're running as far as the tool internal tool number, you need to accommodate for how many edges you're using. So underscore TLM1 and in brackets a number will correspond to edge number D1 and whatever the tool number is. And so if you're using a second edge, D2, it would look like this, TLM2 and however the tool number. Same thing for edge 3, TLM3, and so forth, all the way to D9. I've wrote this logic up to be able to accommodate 9 different edges, because all the Sinumerik controls that I've seen so far limit you out at 9. So that's kind of where I stopped it as well. I don't know who out there is running 9 different edges, but somebody might be, so I wrote the logic too. So what I want to do now is come back into run my virtual machine. I want to kind of explain this a little better so you can see it, what it actually looks like. So if I go over here to my R variables and I select global GUD, this is going to be defaulted to whatever GUD the manufacturer is using, and it's not the one that I want to see. I want to go to GUD selection, and I'm going to select this GUD4, which is the one that I created. So here's the variables that I created. So TLM1, and they always start with 0. So I started with 0 and I created up to 30. So that's all I create. I can add to this as many as I want. I can create whatever variables I want. But for now, I knew I didn't have 30 tools in, so I only created 30. So you can see it's already gathering some data from us running this part a minute ago. So how do we get this to this point? How do we create these? Well, if I go over to my setup page, now access key switch 3, access level 3 will not let you see the folder that I'm about to show you. So what we want to do is put in a password. We want to put in the password for at least the user level. So you need user level access or higher, manufacturer or something like that, to see the folder that I'm about to show you. So if we go into system data and we go to NC data and definitions, here is where you create a GUD. So you can see all the GUDs that's currently created. I would highly suggest creating your own GUD just to make it easier to work with. But what we want to do is go to new, and I can fly this down and see all the available GUDs that I have. Now, I would recommend that if you have these numbered GUDs, I would use those first. This is going to vary between manufacturers. Some of them might be used by your manufacturer. Some of them might just be locked out and they don't let you use all of them. But I would try to use that first if that's available. And if it's not there, then I would use this UGUD. That means user GUD. So what you do is you'd select one you want to create and hit OK. I'm not going to create another one because I already have one here. But eventually, so what you're going to see is when you hit OK, it's going to pop up with this screen. It's just going to be a blank screen with M30. Now you see I've got this line here. This is what's defining my global variables. So the syntax for this is DEF for define. I'm defining an NCK, which is a global variable. It's not channel specific. It's global to the machine. And I'm defining an integer. I'm not really caring about seconds, so I'm not defining a real number. I'm defining a whole number here, so an integer, because I don't care if my tool lasts 17 minutes and 14 seconds. Just round that down to 17 minutes, or 17 minutes and 42 seconds. You know, just round that up to 18. So I'm just defining an integer. And then the last one here is, this is our syntax for our global variable. Now it needs to be underscore TLM. And if you're using D1, which all of us are. So it's going to be 1, and then however many variables you want to create. So if I want to create 40 of these, let's say, I want to change this and I want to say 40. If I create 40, it's actually going to go to TLM 139 because, like I said, when you do it this way, it always starts at 0. So if I want to go to TLM 40, I want to put in 41. Now, when you create this, all I have to do is come over here to my over arrow and go to close. When I close this program out, it's going to say, do you want to activate this definition? And I'm going to hit OK. Now, if this is the first time that you have created this, you're not going to get this pop-up. You're going to just get something that says it completed successfully and just hit OK. But since I'm amending this, I'm getting this pop-up that says, hey, do you want to keep the existing values that were there for these variables that you already created and just add to it? Or do we want to reinitialize the whole thing? So I'm just going to select this and hit OK. That's going to reinitialize the whole thing, which means any data that I have there, I'm going to lose it. And that's okay for what I'm doing. But if you don't want to lose your data, select the first option. So you're going to get this as it's completed successfully. Now I can hit OK. Now if I go back to that tool parameters page, go over here to my global variables. Like I said, if you don't see it pop up, go to GUD selection and select the one that you just created. In my case, we did have 30 here, but now you can see we have 40. So it's very important that you create enough variables to cover how many tools you're using and how many edges you're using, because you will get an alarm if there is not a variable there to write to. Okay, so if I come out of this, how we find what variable this is writing to, if I come over here to my tool list, now remember underscore TLM1 will always be D1, and this number that's in the bracket is going to be tied to the internal tool number. So if I come to my tool list and I highlight a tool, if I hit this over arrow here and I go to details, and now at the bottom here, I see internal data. If I click this, now I will see this tool number. This is the internal tool number that is created every time you create a tool. It's unique to that tool and it will never be duplicated. So there won't be 2 tool 3s in here. So if I cycle through these, I can see this number change. That one's tool number 8, 7, 6, 5, 4, 1, 2. So I haven't created many tools in this environment, so that's all I've got. And but you certainly, if you've got a lot of tools, what I would do is when I go to create my global variables, you need to know how many to create. So I would come to this page, go to my internal tool data or internal data, and I would highlight each one of my tools and see what number is the highest number. And that would give you a good indication of how many variables you need to create. So I want to really stress that this tool, this number is not duplicated. So it's just going to keep adding to it. And just because I name a tool a number doesn't mean that that's going to be tied to the internal tool number. So if I create a new tool here and I name it tool 5 or 5, just know that when I go in here to my details, that's actually internal tool number 10, because this is just a name. It's just a string variable. It's not an actual number. So keep that in mind if you are numbering your tools like this. This is not your internal tool number. Okay, so another thing I want to talk about, now that we understand how many variables we need to create based off how many tools we have, is our edges. So if I go back to my program manager, I've got this program here. It's the same program that we've been running. The only difference here is, actually, let me reset this. I didn't create it. The only difference with this program is my finishing tool that runs along these walls. I'm finishing the outside with D1, and I'm finishing these pockets with D2. So I need to create that. So if I've got a tool, this 3/8 finishing tool, and I go to edges, and I say new cutting edge, there's my D2 for this tool. Now, if I go to my toolware, let's just say I want to add this to time, so it's counted by my my macro. So now I've got an edge there, and I want to go to my R variables and make sure that I'm tracking tool life. I'm just trying to show you here what's going to happen if my program is running a multiple edges and I don't create that variable. Same will happen if we don't have enough tool numbers, or if our tool number exceeds the amount of variables we created. Sorry, I hope I'm not making this more confusing than it actually is. So once we get to that 3/8 end mill, we should get an alarm right there. Syntax error in text, underscore TLM2 in an open bracket. What it's telling me there is that global variable doesn't exist. So if I want to run that, I will need to amend my global variables and create this variable. So what I would do now is I would go to my setup, go back to my GUD, and all I'd have to do is I would copy this, copy it down, and then I would say TLM2. And I would want to create this. I would probably create the same amount of variables just to make sure that I don't, if I decided to add an edge to tool number 40, I'm not going to get an alarm and have to do this again. So by adding this, now I'm going to create another variable. I'm just going to reinitialize this. But we should see that pop up now. And now I would be able to run this program because the variable does exist. All right, once that's okay, now we go back here and I open up my global variables. I see TLM1, 0 through 40. And now I see underscore TLM2, 0 through 40. So now I can cover any D2 up to 40. Okay, so I really wanted to stress that to you, that however many edges you're using, however many tool numbers you're using, you'll need to create the appropriate global variables. So now if I hit cycle start on this, it would run and it would not give me that alarm. So I want to come back here and talk about some of the limitations. Now we're almost at the finish line here. But you might have seen this right off the bat. And one of the limitations is that doing it the way that I'm doing it, calling it up as a sub program to record the tool life and to write the tool life, that means to record the tool life, that means I'm having to run the entire tool path all the way down to the M1, or when that tool is complete. It has to complete its cycle and read that program before it writes that data to the variable. So that means that if I've got an end mill that's going to run for 20 minutes and it ran for 15 minutes and broke, and the operator seen it break and he stopped it, reset the machine, changed the tool out, touched it off, and reset the tool life and hit go again. That means it didn't complete its cycle. It didn't get down to that tool life record program. So that means that last 15 minutes that it ran, it didn't capture. So your reports may not be 100% accurate. Now, there might be an argument there that says, well, if it's running for 20 minutes, it didn't need to add that last 15 minutes anyway, because it can't make it all the way through the part. Yes, that's true too, but my point is it's not going to be 100% accurate. And I'm okay with that for the reasons that I explained earlier. The way this is written is to get you going fast, to get you up as fast as possible and easy as possible so you can start tracking your tool life without something that's super complex. Now, another limitation is that we are still dependent on that operator to reactivate that tool life when he changes those tools, like we seen earlier. If he forgets to do it on one and he runs it again and then he remembers to do it, well, he just doubled that. It's going to output twice as much tool life as what it actually ran. That is a limitation as well. And how I would combat both of these is what I talked about in the beginning, how you can get away with all the limitations and it would be better, but more complex. What I would do in a real life environment is I would probably add this, a combination of these two macros. I would add them to the tool setting cycle. So the cycle that actually sets my tool length. I would edit that cycle, and in there, I would record the tool life. I would write it to the macro or the variable. I would write it out to the, if it's a new tool, I would write the data out, and I would probably reset or reactivate the tool and not ever have to worry about the operator doing that for me. I would do it right there in the macro. The problem is with that, and the reason why I didn't show you that and didn't write it to do that is because that's inherently more risky, right? Now we're talking about changing the cycles of my machine. I'm changing a very important cycle that teaches the tool length of all my tools. If I was to delete something there or skip something that needed to be read and I messed that up, well, next thing you know, my machine is down until I can get somebody in here to give me the original program or whatever. So I could really mess something up. And I want to avoid that situation if all possible. The way I have wrote this is to be able for you to implement this really fast, really easy, and then you can work on the better solution that I just mentioned. But this gets you going really quick. And the last one is not really a limitation, but it is something that annoys me. And that is if you're using multiple edges like we just saw, the output that you would get is this. So it's going to look the exact same. The only difference is you see the D value change for the edge. So if you're doing something like an end mill or a face mill or something like that you're using multiple edges, you would have to add these two together to get a true tool life. So this tool actually ran for 35 minutes. That's just annoying to me. You know, if it's really written for multiple edges for, you know, if you're running a multi-tool and you got a roughing tool on one side, a finishing tool on the other, obviously those two inserts are going to last differently. So you will be able to capture that data. But this is just something to keep in mind. I want to be fully transparent with you and to keep it in mind. So that's really all I got for you today. Like I said, I will get these macros to anybody who wants them. And so now I guess if there's any questions that anybody has, feel free to ask them now.
So we had a few come through. One of them is, can you just elaborate what a sister tool is?
Yeah, so a sister tool is a second tool that you put in that is mimicking the first tool. So like I said, if you got a 1/2 inch end mill that roughs your part or finishes your part, whatever, that 1/2 inch end mill has a 30 thousandths corner radius and it's got an 1.25 inch length of cut and it's in a hydraulic holder. That's the tool that you've chosen to run your part. Well, if I want to add a sister tool or redundant tool, what that means is I would build that exact same tool, a real life physical tool, in the exact same holder, preferably the exact same holder. That's, you know, if we're talking about best practices, that's what you would do. And I would input that into the machine and create that tool like I saw, just like you would your normal tool. I would create another tool and I would name it the same exact name, end mill _1/2 _rough, because it's the same exact tool. And all that's going to do is it's going to be, you're going to touch it off just like you would your other tool, everything. The only difference here is it's going to say sister tool 2 in this column instead of 1, or 3 or 4. You can have 3 sister tools if you want. So it's just a redundant tool in there for when you set tool life management. You set it up. When this one reads 0, it will automatically call the second tool up if it's there, and your machine keeps running.
Thanks for that. That's a good one. Yeah. Just the same exact tool, same physical tool that you load. So you have 2 half-inch end mills in the carousel. Very good. Get another one here. How would you use wear in tool life management yourself? Like, how would you subjectively use wear?
Personally, I've only ever used it manually. So that means me measuring the part myself, going in and manually adjusting this number to make the finish size more intolerant or whatever. I'm not a big fan of using laser setters and other tool setters to set my wear comp for me. I've never seen it be accurate enough. Now, there might be some people that are using it that love it and it is accurate for them. That's great if it is, but I've never seen it. So I would really shy away from doing that and having it update this automatically. Or a probe. I've done measure, cut, measure, with a probe. I would set my tool wear that way. I would come in and probe the part, let it adjust the tool for me, and then set wear or set the wear for me. But certainly for this number, for how much wear you're okay with going to, that's going to be a judgment call on your end, because tools are going to wear out at the bottom before they wear out at the top. So always, if it's an end mill or something like that, this part's going to start flaring at the bottom. It's going to get bigger at the bottom than the top. And what point is it acceptable to you? It will determine what value you put into your wear comp here. If you're using tool life management wear, that is.
And then I got one more here. Can you change the R comments from a program? Can you write to the R comments from a program?
So these comments here, no,
Yes.
you cannot. Yeah, this is something you have to set manually. You have to type in
Nice.
the comment itself.
And then if we have any other questions coming into the chat, I think there was maybe a few more here. Let's see. Yep, we answered the question about, are we going to share this? We're definitely going to share this. And then, is it useful for 5-axis grinders? Is something that can be changed for adaptive control? I think this is huge, especially in grinders, because you could use this for the wheel. And really the wear that we just talked about, wear in grinders probably comes a little bit more into play because you are starting to wear that wheel quite a lot. So you might want to check either, time or in wear, and actually have that as it starts to degrade the wheel. So I think that is definitely a good one. So we answered that. I don't know if anyone has any questions, they can put it in the chat. We'll be more than happy to answer them. If there's no other questions, we can wrap up this webinar, and I appreciate everyone coming to it. And thank you so much, Jessie, for putting this on. I really appreciate it. You've done so much work into this macro, and thank you for making it available. Some people already put in the chat that it's nice that we're making it accessible. What I'll do is, when we get done with this webinar, I will put it all into our YouTube channel under Mr. CNC. So subscribe, and we will have this webinar will be up there, as well as the macro and all the details to make it, to repeat it. So if you have any other questions, you can put it in the chat, or you can email myself or Jessie. Thank you for coming to this webinar, and Jessie, thank you for being a guest speaker.
Yeah, thank you for having me, and I thank everybody for your time on this, and I hope it helps everybody out.
All right, perfect. Thank you.
Yeah, man.